it's also possible that we were just created. And we just think we have a past.
I think capacitance is going to change.
What was that?
The capacitance is going to change.
Why?
Well, if the voltage is no longer constant, but the Q is constant, then something that's going to change.
Well, with the formula, it doesn't really meet the charge. Well, for the plate capacitor, so would it change? I don't think it would, because the numbers don't need to change.
Which formula are you looking?
I'm looking at the kappa epsilon area over D.
I'm looking at the Q over.
All right, so first off, parallel plate capacitor. All right, so this formula holds. If we disconnect the battery, does any of this change?
No.
All right, so my capacitance will stay constant. My charge has stayed the same. My capacitance stays the same. So based on the formula near the top, the C equals Q over delta V, what's going to happen to the voltage?
It's the same.
So my charge has stayed the same. What about my total electric field?
They'll be the same.
My plates?
The same.
Dielectric?
The same.
Yeah, there's still no dielectric. Yeah, all I've done is disconnected. I haven't changed anything else in the configuration. Now, what happens next, though, is affected. So what we're going to do is we are going to, if we assume that this is d sub 0, I'm going to double that distance. And I am going to add dielectric with a dielectric constant of 3. So I've taken this situation, I've now spread it apart, and I've magically filled all of that area with some cover, there we go, with a dielectric constant of 3. All right, so first off, is there anything that we know is not going to change?
The volts, or voltage, the change in potential.
Voltage and change in potential, synonymous, so one or the other, or both, sure, why not? Why would you say the voltage will stay the same?
Because it's still the same amount of energy, and considering we shouldn't lose any energy between the two plates, the circuit should still keep all 20 volts.
It's related to energy, but it's not energy itself. And the voltage is not the same.
The charge is going to stay the same.
Yeah, we've disconnected the battery already. This is still part of the sequence there. We disconnected the battery, so charge will stay the same. So if charge stays the same, what else will stay the same?
The electric field of the plates.
And my capacitance?
Well, that's gonna be cut in half.
Well, more than that, because K changes.
Oh.
So what will be the final capacitance? Even surely you're not using a calculator right now.
Wait, hold on.
Which means that you're texting or something, which is worse.
I was about to use the calculator. I mean, unless you want us to do that in our head. 3 times 8.85
Oh, you're making it far more complicated.
Oh,
Do you just,
What's changed?
the bottom, the point one goes to point two.
Alright, so we've doubled the bottom. What about the numerator?
It's triple.
Yeah, so what is the final result compared to what we started with?
Is it 3 halves bigger?
Yeah. It's 3 halves bigger. So my capacitance is 3 halves of what we started with. Now, if you wanted to come out with an exact number, you would, yes, use a calculator, or slide rule, or abacus, or whatever you happen to be, you kids use today.
ChatGPT.
What was that?
It's a ChatGPT.
I'm trying to think if I've actually used it just for plain old math. I've done it for solve for the unknown. It's
One time I forgot,
questionable whether it works or not.
my brain just stopped working, and I needed to figure out how to calculate this equation. So I was like, I tried using one of the other math apps, didn't work. I was like, okay, ChatGPT, do you think? And so, it created its own math rule, and, did it from there. And so I'm like, okay,
Was the math rule correct?
not even a little bit, not even close. I was like, come on, this is like,
I typed into ChatGPT, who's the most beautiful woman in the world? It did not give me an answer. It said, beauty is in the eye of the beholder.
Does that say disconnected by in the middle column?
Disconnected battery, disconnect.
thank you.
All right. So, back to physics. We got some blanks here still.
Would the total stay the same? Because the plates stay the same?
The total electric field, we have a dielectric now though. So, when the dielectric shows up, the total on the plates will not be the same. I would think delta V, the voltage across the plates would be the next easiest thing.
That'd be the same though.
Why?
Well, I think it'll,
Oh, hi.
Feel free to tag team if you need to.
Well, when looking at the board, the equation id, the d got larger, so it would be
well, 3 times,
the,
No. 2 times.
yeah.
All right, so this one right here, it looks like you were using this equation. This is the total electric field,
Okay.
which we don't know yet.
Mm.
And we don't know that yet either. So the only thing we know is delta X, that doubled. So not enough information really to use this one yet.
Is that E the same one and the other one? The id, the one right next to it?
That E is, yeah, that E is the same. Yeah, this is just the shorthand. Let me leave some detail out of it because you're just supposed to know. This is probably the formula that I would recommend here. Because we know Q is the same. We know that the capacitance increased by 50%. So what happens to delta V?
Because of,
It goes down 50%?
Not the way you just worded it. I think the spirit of what you're saying is right, but
it decreases.
less in the spirit. So I know that C sub naught is equal to Q sub naught over delta V sub naught. That's where we started. But now my capacitance is 3 halves of C sub naught. So now I have 3 halves C sub naught is equal to Q sub naught, because that hasn't changed, over delta V. So what is delta V?
Delta V is
My thing would be like,
Q over 3 halves C sub naught.
Okay. And something over 3/2 is the same as 2/3. So from here, I know that delta V sub naught is equal to Q sub naught over C sub naught. From here, my delta V is Q sub naught, 2/3 Q sub naught over C sub naught. So it's 2/3 of what we started with. Now, I have on the test set it up like this, and I said, just do everything in terms of E sub naught and C sub naught and so forth. Just because, for me, that is just a whole lot easier than having to pull out the calculator and deal with, these large numbers. But not everybody's mind works that way, so if, on a problem like this, if you want to do everything in terms of delta V sub naught or E sub naught and so forth, that's fine, or if you want to actually crank it out on a calculator, that might work better for you, some of you. All right, so now we can do electric total.
It would just be. Well, even without that, we do like the electric total, but just doing the charge over A, and then we figure out that, and then.
Wait, sorry.
Say
that again?
You would do the charge over A to get, I forget the name of that symbol. Sigma, and then the sigma over epsilon.
Yeah, recognize that this epsilon right here
Yep.
is kappa times epsilon sub naught.
Well,
Yeah, we can do it that way. So area hasn't changed, Q hasn't changed, so sigma is the same. Kappa is 3.
And epsilon is still 0, so it's the same.
Yeah, I hope so. Otherwise it has spoiled the name of constant.
Or you can do the voltage divided by the D,
Okay.
and so then you'll get 2/3 voltage over 2, and then that's the same as 3 E. Not how math works.
2/3 divided by 2?
Yes.
Is it not?
It's not what?
0.2.
Oh, 1/3.
It's 1/3.
1/3, yeah.
It's 1/3. Or if you had done it this way over here, sigma over epsilon naught's what we started with, and then divide by 3. So my total electric field is going to be 1/3 E sub naught. So my total electric field between the plates is dropped. And we're left with the dielectric. Three.
Yeah, I was just saying.
Mathematical Tourette's. Randomly thrown out numbers.
Is it negative 2/3 E sub naught?
All right, so it would be the difference between these two, because I have this electric field coming from the plate, so I have this electric field going to the right of some value E sub naught. I know that I also have, let's see if we can get this thing to actually change. I have this back electric field caused by all the polarization of the molecules in the dielectric, and that will give me, and so this is my E sub D for dielectric. So I know that the total, E minus E sub D, is going to be equal to my total. So so I have this minus that will give me this. Because I put in the magnitude here, it's gonna be positive 2/3, but negative 2/3 definitely within the spirit of what I'm looking for there. This is just the difference.
Now, in a situation similar to this, but like let's say we tripled it, the distance, or kappa was a different number, would the idea of just doing like the 50% more still work? I know, I assume it would be a different ratio, but.
Yes, it would be a different ratio potentially, and it should still work. I'm pretty sure there's a master set question that deals with this. And, oh, you can be sure there's gonna be a test question along this vein somehow. Although I did change it, I got bored of these type problems, so I started throwing in I gave the initial conditions of the capacitor, and I said you can change, then I gave a list of things that you could change. How can you change it so that the capacitance is doubled, but the total electric field stays the same? And then you try to figure out how to do that. Or if it can't be done, show that it cannot be done.
Would you, I'm just throwing out an answer, would you change the distance between the plates?
There's usually multiple steps, but what did I just say? Double the capacitance?
Without having the electric field
Change.
So if I double the capacitance, I can double the capacitance one of two ways. I can either cut my voltage, keep it connected to a battery, cut the voltage in half, or I double the current, or double the charge. If I double the charge, I know that the electric field from the plates is going to double.
for sure.
So I would have to add a dielectric if I'm going to go that route. The dielectric probably with, since that's doubled, I want to cut it in half, so add a dielectric with a constant of 2. And that's the type of processing. Or if I cut the, let's see. Yeah, probably for that, there's probably 5 different ways of doing it. Questions? Doing okay, Hazel?
Or could one have questions when he has 2 boards looking like this?
Tristan?
The plates and the total, are those the same?
The plate and the total,
Was it like?
at this point right here, the plate the electric, since the charge on the plates hasn't changed, the total, the electric field from the plates has not changed. Because the dielectric was put in there, the total electric field was cut by a factor of 3 at this point, and then therefore the dielectric was offsetting the difference between these two, which is 2/3. Does that answer your question?
Yeah.
And Ethan, you were about to ask something?
Yeah, will we have those formulas on the test?
Yeah.
All of them?
I think so. I feel like we need to, where are we on time? Okay, plenty of time. All right. I feel like we actually should answer that if I went to double capacitance. So let's get rid of some of this stuff.
Oh, can I ask another question real quick? What's the difference between the 2 delta V equations on the bottom?
These?
Yeah.
This is more formal. Throw in the integral and a dx and you have the real version of it. But if the electric field is constant in space, so no matter where you are between the plates, the electric field is constant, then it breaks down to this. This is just a shorthand way that some textbooks will write it, and they drop the minus sign, they drop the, you know, all the decorations, and sometimes books will just go so far as to write it that way. So this is just a very shorthand, it's a shorter hand notation of this. But this is still the totally electric field. This is the distance between the plates. We're ignoring the signs, the fact that the potential drops when in the direction of the electric field.
So we're just gonna assume that the person who's doing this math knows that it's gonna be negative.
Yes.
Otherwise, the vector's banned.
You know, if you know all the stuff already, then you don't need any equations, really.
Now, if someone made a small, teeny tiny mistake and forgot the negative symbol, would that be a catastrophic mistake?
That's what I'm actually testing as a question. Or if you're Jack.
Or if you're Ibrahim.
Or Ibrahim, that's right, sorry, Jack or Ibrahim. All right, so let's actually answer that question of doubling. So I want capacitance to equal 2 times the initial capacitance, and I want the, I think I said totally electric field?
Yes.
All right, so if I don't want to add an dielectric, if I cut the distance between the plates in half, that would double the capacitance. But if I double the capacitance there, by changing the configuration, and it's still connected to a battery, that means my charge doubles. And if my charge doubles, then since sigma is Q over A, this is Q over A epsilon sub naught, and Q over A kappa epsilon sub naught. So if I double this, then my total electric field doubles. So if I want my total to stay the same, I can either manipulate more than one thing here, or I can fix the charge.